Solve by elimination. 2x plus 3y equals 12, and 3x plus 2y equals 8. In this problem, both of the equations are already in standard form, with the x and y terms on the left and the constant term on the right. But if we try and line them up, nothing's going to cancel. We could write 2x plus 3y equals 12, and 3x plus 2y equals 8. But if we add them together, we end up getting 5x plus 5y equals 20, which isn't terribly helpful because nothing cancels. However, this one's going to be more difficult because we can't just multiply one of the equations. If we wanted to cancel out the x's, we note that we have 3x here and 2x here, and 3x isn't a multiple of 2x, so it's difficult to multiply by something to end up with terms that cancel. The same problem happens with y. We've got 3y and 2y, and 3y isn't a multiple of 2y. Technically, we could multiply one of these equations by 1.5 to cancel out one of the variables, but multiplying by 1.5 is a bit of a pain. So instead, we're going to do something different here. We're going to try and multiply both equations so that we can get a pair of terms that cancel out. And I'm going to write that down. We're going to multiply both equations to get a pair of terms to cancel. Now we can focus on the x's or the y's, but let's focus on the x's. When we look at the x terms, we have 2x and 3x, and we want to get both of those to be in a situation where they'll cancel out. Now if you look at 2 and 3, and we ask ourselves what number is a multiple of 2 and 3, the answer ends up being 6. So what we're going to want is 6x and negative 6x. If we can manipulate those equations so that one of them has a 6x and the other has a negative 6x, then when we stack them and add them together, the x's will cancel. Now let's start with the first equation, 2x plus 3y equals 12. If we want that 2x to become a 6x, the easy way to make that happen is to multiply both sides by 3. So let's multiply both sides of that equation by 3. 3 times 2x gives us the 6x that we wanted. 3 times 3y gives us 9y. And on the right-hand side, 12 times 3 gives us 36. So we've got our 6x from this equation. Now we want to take the other equation, 3x plus 2y equals 8, and we want there to be a negative 6x there. How can we take 3x and turn it into negative 6x? Well, the answer is that we multiply by negative 2. So in this problem, we're going to multiply both sides by negative 2. On the left, negative 2 times 3x gives us negative 6x, which is what we wanted. Negative 2 times 2y gives us negative 4y. And on the right, 8 times negative 2 is negative 16. So now we have the two equations, and we can stack them and eliminate the x's. We've got 6x plus 9y equals 36. And negative 6x minus 4y equals negative 16. When we add these together, 6x minus 6x is 0. The x's cancel, which is what we were hoping for. And now we can just deal with the y's. 9y minus 4y is 5y. And on the right, 36 minus 16 is 20. So we have 5y equals 20. And if we divide both sides by 5, that gives us y equals 4. So we know that y equals 4. Now to find x, we need to plug this into any of the equations that has an x and a y in it. I'm going to pick the second equation, 3x plus 2y equals 8, because it has some of the smallest numbers in the problem, and maybe that'll make the arithmetic easier. So we have 3x plus 2y equals 8. But we've seen that y equals 4, so we're going to have 3x plus 2 times 4 equals 8. Now, 2 times 4 itself is 8, so we have 3x plus 8 equals 8. To get the x alone, we're going to subtract 8 from both sides. This gives us 3x equals 0. And if we divide both sides by 3, that gives us x equals 0. So our final answer is x equals 0 and y equals 4.